Okay, so here's problem number 5 from section 7.4, I think. Right? All right. And the idea is that we have this curve, and we're going to find the arc length distance, the distance on this curve from that point to that point. All right. Now, we have a question. We have a choice. Our choice is whether we're going to do this in a dy dx or a dx dy fashion. Because we have two formulas for arc length. Arc length is the integral from a to b of the square root of 1 plus dy dx squared dx, but it's also equal to the integral from c to d of square root of 1 plus dx dy quantity squared dy. This one is great when y is a function of x. This one is great when x is a function of y. What is your pleasure? Function of x, because it's going to be easy to isolate the y in this equation. Because that's what we're saying here. We're going to isolate the y and get all the x's on the other side.
Yesterday, didn't you isolate the x and then switch the variables and then switch the...
I did that on a problem yesterday when we had a problem with lack of smoothness.
Again, they cannot see the motion on the
No, they cannot.
recording.
And in this case, I don't have a lack of smoothness, so I'm not worried about it. I'm at a loss for words, Trevor. All right, so I say we're going here. That's what I say. But what do I think? I think rain is wet. All right, so I say that we're going to go from C to D, where C is a y value and D is the other y value. From -1 to 3. Square root of 1 plus, I need to find out what dx dy is. And remember, dx dy is just a fancy way of saying g prime of y. So what is my g function? What is x equal to? I think my x is equal to 1/2 y squared plus y minus 1/2, I think. Boy, I did that really quickly. Let me do that in multiple steps. I don't like that. Let me do that in multiple steps. All right, y squared plus 2y is equal to 2x plus 1. My goal is to isolate the x. So I'll subtract 1 from both sides. And I get that. Now I'm going to divide both sides by 1/2. That 2 goes away. Plus y minus 1/2 is equal to x, and that's what I'm declaring to be my function g of y. Now what? Now let's find out what g prime of y is equal to. I don't know, did I do that right?
Yep.
All right. So that's the thing I'm going to take over to here. And there I have it. There's my setup. Once I get there, what do I have? I got something I don't believe that I can find the value of that antiderivative analytically. I think I'm going to go to the calculator. Where's my calculator? Oh! Oh, there we go. Ow. That's that. There we go. All right, alpha f2, and there's my finite integral function. I'm going from -1 to 3 for the function that's the square root of 1 plus parenthesis, and instead of writing in y, well, I could write in y, couldn't I, if I wanted to? I tended this step just to substitute x's for y's. Is there anything to be gained by leaving it in y?
No.
No? So
It's just a variable.
it's just a variable, it's just a placeholder. I could call it motorhome if I wanted to. I stole that joke from somebody else. And we're going to do the derivative with respect to x. We realize that that expression should all be in y's, but we're too lazy to do it in y's. And so that's what I think our arc length is. How's that compared to the answer in the back of the book? Same? Different? Reasonably close? Nailed it? Survey says, Emily?
It leaves it, it doesn't solve it in the calculator, it leaves it as the.
Yeah, it does.
Yes, it does.
9.294.
Hey! So, you're not able to find
Oh, I found it.
Okay, great. So, we did it. Hooray. That finishes off that recording.